All right, lesson 13 is on adding and subtracting fractions and mixed numbers. What's our objective, class? Get ready?
Adding and subtracting fractions and mixed numbers.
Very good. We're going to look at some of the uses of fractions when we add and why we add and why it's easier to do what we do. What are the applications? Well, measurement's a big one. You've all had pizza, all right? And your mom says, hey, can you throw this box away, take these 2 pizzas and put it in the other box to save room, right? So you had 3/8 of a pizza left here and you had 2/8 of a pizza here. So altogether you had, we're going to move those over, 1, 2, 3, 4, 5/8 of a pizza. So the math behind that is 3/8 plus 2/8 equals 5/8. So the denominator doesn't change when you add fractions. You have to be common, but the denominator doesn't change. You only add the numerators. What do you only add? Class, get ready?
Numerators.
Numerators. I bet most of you knew that and remembered that. Let's try a few that have common denominators. Then we're going to change it up and make it a little bit harder more for course 3. So if we add this, denominator stays, get ready? 4. Sorry, you didn't know what I was asking. A 4, the denominator stays a 4. Our numerators we add, which is, get ready?
6.
6. If you can reduce a fraction, always reduce a fraction. So they both are a factor of 2. We're going to, or a multiple of 2. We're going to divide out of 2. We get 3 on top, 2 on the bottom. It's an improper fraction, but in course 3, it's okay to leave your fractions as improper.
Really?
You can also leave it as 1.5. Both answers are okay. Let's do 3/5 minus 3/5. First of all, the denominator is the same, so our answer will have the same denominator, which is, get ready?
5.
And our numerators subtract 3 minus 3 is, get ready?
0.
0. 0 divided by 5. 0 is so small. 5 couldn't fit in it at all. 5 can't divide into 0. That's how you can remember that 0 divided by anything is 0. Nothing can fit in 0. Okay, on the bottom one, I'm going to scroll up a little bit and work on this one because I had a lot of students yesterday. They were a little rusty on finding a common denominator. We cannot add until we first find a common denominator. What do we need to first find? Get ready?
Common denominator.
A common denominator. I'm seeing eyes up here, but I'm also seeing you take notes, so this is good. All right, so our common denominator, we're going to look for the least common multiple. The least common multiple. Meaning multiples of 3 would be 3, 6, 9, 12. So count up. Multiples of 4 would be 4, 8, 12, 16. Which one was the least common one? Get ready?
12.
12. Do both 3 and 4 divide into 12? They do, without a remainder. So 12 is the least one that 3 will divide into, 4 will divide into. So what would I do to my 3 to turn it into a 12? I would multiply it by 4. If I multiply the 3 by 4, I also have to multiply the 2 by 4 because I'm really multiplying by 1, my identity property, right? I'm multiplying by 1, so I'm making an equivalent fraction. So on the top, 2 times 4 is, get ready?
8.
8. On the bottom, what would I multiply the 4 by to get a 12? Get ready? 3. So I'm also going to multiply the top by a 3. 3 times 3 is, get ready? 9. Now that I have a common denominator, I'm going to add the denominator stays at 12. I add the tops, I get 17 12ths, which is okay. Or I can say 1 and 5 12ths. All right, this one, I'd like you to find, you do this mentally, what's our common denominator? Common denominator. As soon as you think you know, put your pencil up. This helps me to know where we're at here. Okay, I said it and got it. Least common multiple, common denominator. All right, let's get help from Aubrey.
12.
She says 12. How did you know it was 12?
They both go into 12.
They both go into 12. Well, they both go into 24.
Yeah, but 12 still is common.
12 is the least one. Okay. What about 8? Why wouldn't it be 8?
Because 6 will go into it.
6 can't go into it. 4 can, but 6 can't. So you have to pick a number that both numbers can divide into without a remainder. All right, so we're going to times by 3, right, to get our 12. So we'll get a 9 on top. Times by 2, 1 times 2 is 2. Now we work straight across. Denominator stays the same. Numerator subtract, I get 7. And that one is certainly a proper fraction. You can leave it there. Any questions? Let's take it up a notch now. We do this on the volleyball team. We start with basic drills and then we add on and make it more advanced. So we want to stretch our brains, right? So now we're going to do mixed numbers. Holy moly, we've got mixed and not common denominators. So we're going to change a few things. Now remember in elementary school, when you added, you would do a vertical thing. You'd go like this. And you would say, oh, I still need a common denominator. So you change that one to a 4. I would be timesing by 2, times by 2. So I get 2 fourths plus 3 fourths would give me 5 fourths. And you would do 3 plus 1 is 4. However, that's an improper fraction. You can't have an improper with a whole. So we're going to change the 5 fourths into another mixed number. So this is how you do it. 5 fourths would be the same as 4 plus 1, right? The 5 would. Let's just look at that. Would you agree 5 fourths could be split up with 4 fourths plus 1 fourth? Would that be 5 fourths? Yeah. If not, if you agree. I just want to make sure you're still with me. Okay, good. So isn't this 4 fourths a 1? So I'm going to take that 1, add it to the 4. That gives me 5. And then I've got a 1/4 left. A shortcut way is to just subtract 4 off of your 5 and then turn this 1 higher, and then that remainder part becomes your numerator. Some of you might have learned that shortcut. The way we're going to teach this in middle school, though, I'm going to show you on this one. We're not going to do it vertical. Instead, we're going to do improper fractions. Improper fractions, that's when you take the denominator, multiply it by the whole number, add the numerator. 2 times 3 is, get ready?
6.
6. 6 plus 1 is, get ready?
7.
7. So that's your new numerator. Your 2 remains as your denominator. How about this one? 4 times 1 is, get ready?
4.
Uh-oh, I lost some of you. 4 times 1, get ready?
4.
Then add on the 3, get ready?
7.
Good. Keep your denominator the same. Okay, 7 halves minus 7 fourths. Can I add the numerators match? No. Denominators have to match. Think of pizza, right? I gotta make it fair. I gotta make the slices the same size. All right, so let's change this into a 4. If I want to change the 2 into a 4, I would multiply by 2. So I also have to multiply by 2 here. That gives me a 14. So I have 14 fourths minus 7 fourths. Gives me 7 fourths. That answer is okay. It's improper, but it's okay. Or you can say 1 3 fourths. Now, if I was a carpenter and I went to Home Depot and I said, can you cut me a board? Back at the back, they have this big saw and they'll cut it for you. I've done it a lot of times. So can you cut me a board? I need 7/4 of a foot. Do you think the guy's not going to know where to cut it at?
No.
He's not going to know. But if you said, I need a board 1 3/4 of a foot, he can do that. Okay? So you'd look at the feet. I'm sure I got my feet side. It's a weird.
Some meter stick?
That one, well, yeah, but it only has inches. It doesn't have feet on here. Here's this one. Okay, this one is the same way. But here's my 1 foot is to right here, the 12. And 3/4 of a foot would be 9 inches. So 21. He could cut that. But if you tell him 7/4 of a foot, so where do I cut that?
He's like,
Okay. So when we're dealing with measurement, it would be best to put your answer in a mixed number. You have one on your practice set like that. That's why I bring it up. Your general rule. When you add fractions with unlike denominators, first get a common denominator, then add or subtract your numerators, regroup if necessary, and simplify your answer by reducing. So here's the Home Depot question. You go to Home Depot. Guess what? 2x4s aren't really 2x4s. They're actually 1 3/4 inches. That's an inch mark. By 3 1/2 inches. So my question is, if I took 2 boards and stacked them together, this is 1 3/4 of an inch. This is 1 3/4 of an inch, and the question is, how thick is it stacked together? Will you solve that on your papers? Put your pencil up when you have the answer. You got it. Some of you, if you cook in the kitchen, I think cups of flour. I can do 1 3/4 cups of flour and 1 3/4 cups of flour, so I can do that one kind of quick. I've got Avery, Colin, Bo, Aubrey, Michelle, Jasmine, Josie, Connor, Spencer. I'm going to give you a ticket every time I mess that up. Is that fair?
Do you change the tickets?
All right, let me call on Bo.
So the answer I got is, do you want me to just give you the answer
Yeah.
to tell you how I got
Yeah,
it?
perfect.
Okay, the answer I got was 3.5 inches.
Hey, who agrees with Bo? Oh, you guys are good. I don't know if anybody didn't get it, but how did you get it?
So what I did was, the thing that I usually do first is I add the whole numbers first instead
Okay.
of fractions.
Okay.
So I got
You
2
Two.
and 6/4,
okay?
but the 6/4 can't really be, don't know how to explain it.
Improper.
Yeah,
Right.
it's improper. So what I did was I minus down, so
You still like subtracted the 4 off of that one?
yeah, so that way I don't know if you're good when I have
It's-
to explain.
Most people know that that's subtract the 4, but the reason why you do is because that's equal to 4/4 plus 2/4. So you're going to subtract off that, so you can regroup it with that one and make it 3. And then you're left with the 2/4,
Which then equals
which equals 1/2. Okay, excellent. Any questions? Emma?
It's not a question, but I did it differently. I changed it to improper, and I made it 7/4 plus 7/4 is 4 rows into.
And then 14/4.
Yeah, so
And then
4
just
rows
divide it?
14 every time.
Okay, excellent. Another way to do it. You can pick the way that you're best at. Colin?
Can I say the way I did it?
Did you do a decimal?
No.
No? Okay, what did you do?
So, the last problem we did, 3.5 minus 1 3/4.
Yeah.
It was in my brain at the moment that 1 3/4 was half the thing.
Oh,
So, yeah.
yep. Okay, very good. Smart thinking. I love all the different ideas. I love your participation, so thank you.